In this video lecture, I'm going to show you how an octahedral structure with 3 bidentate ligands does indeed have an optical isomer, or we could say is a chiral molecule. So I made a simple octahedral structure and I represented the bidentate ligands by just connecting the adjacent positions with a piece of tape. And remember, if you have a bidentate ligand, they have to be connected at 90 degrees, otherwise our molecule, the ligand molecule, is too small. The actual way this would look is example here. So the metal center, and then this would be ethylene diamine, NH2, CH2, CH2, CH2. And that would be one bidentate ligand. The next, NH2, CH2, CH2, NH2. And the third, NH2, CH2, CH2, NH2. But when I make the mirror image of this, it's really hard to show you that it's non-superimposable. So I'm going to go ahead and use these simple examples. Same thing. So the first thing you need to do is make sure you have a mirror image. So I carefully constructed 2 of the same molecules. I know they're mirror image because I can see, again, the mirror plane would be between the 2 molecules. I have a ligand going up and towards the center. And then I can see this other one is going out towards you and down. And then lastly, out to the outside and to the back. So they're mirror images. And now when I try to superimpose them, I can see, well, when this top ligands match up, I can see the bottom ones are not. You can see one is going forward and the other is going back. And any way you rotate these, they don't superimpose. So now these 2 ligands match, but I can see that these 2 are different, right? And no matter how you rotate, they will not match up. So that proves that this molecule, an octahedral structure with 3 bidentate ligands, is indeed chiral. It has a mirror image that is non-superimposable. So now let's go ahead and look at an example where I have 2 bidentate ligands in the cis position. So I'm going to remove one of the bidentate ligands from each of these molecules and replace them with a single monodentate ligand. So now the structure looks like this. So again, 2 bidentate ligands in the cis position. You can tell these bidentate ligands are adjacent. These bidentate ligands are adjacent. And I can also see my monodentate ligands are adjacent in the cis position. Let's double check that I did this properly, mirror image, so the monodentate ligands are towards the center and down. I have a bidentate ligand pointing out towards you and to the outside, and lastly up and back. And now we're going to rotate and see if they're superimposable. So when my monodentate ligands match up, you can see how the bidentate ligands are not identical. And if I try to rotate it, there's no way to rotate where these 2 molecules superimpose on top of each other. That means they are non-superimposable mirror images or enantiomers of each other. This molecule is chiral, this molecule is chiral. They are optical isomers of each other. They're enantiomers of each other. So hopefully this helped. The last thing I want to talk about in this video is showing how, so this is in the cis position. Let's prove that the trans position does not have optical isomers. So I'm going to switch my bonds around. So I do indeed have the trans configuration. So the monodentate ligands opposite, the bidentate ligands opposite from each other. And we're going to be able to easily see that they are indeed just 2 of the exact same molecule, or the same molecule created twice. So making sure they're mirror images. So the monodentate ligands up and down, bidentate ligands across from each other as well. And you can see how they do indeed right away easily superimpose on top of each other. The same molecule twice. So octahedral structure, 2 bidentate ligands. In the trans position, these do not have optical isomers. Right? This molecule is not chiral. They are not enantiomers of each other. We do have geometric isomers, right? Cis and trans, but we do not have optical isomers.